So we're gonna deal with inverse proportions today. So last week we've dealt with proportions, and it's basically like how things compare, how a certain quantity compares to the other. But what I want to do here is to show you what happens when you know the relationship kind of become inverted. So what I mean by this, I'll start by going over some of what we went over last time. So last time, right? Proportions. Just a little review, I guess. It's basically saying like when if A is proportional to B, right? Let's say if A is proportional, this means proportional, right? If A is proportional to B, right? That means if A goes up, so will B, right? They're linked somehow. This is 2, this is 3 in the very beginning as a ratio. And when A becomes 4, then B becomes 6, right? And examples of that would be map skills, right? Um, amount of goods, prices of goods and services, the amount of sleep you get to how tall you grow, all sorts of things, right? But those are proportions. These are just simply proportions, right? But what we're gonna talk about today are what happens, you know, when when A increases instead, right? Maybe B decreases instead. Something else happens in there. So we're gonna exactly talk about how to quantify that and what it will look like over here. So inverse proportions means that like basically, so maybe I'll do it in blue. So inverse proportions, right? It's like when A goes up, B kind of goes down. And this is there's a lot of real life examples to this. Actually, can anybody think of any example that when one thing goes up, another thing goes down, that and they're like related in a way? So not here. Can anybody think of any example? If not, then basically, right? You can think of like this, right? Have you guys do your homework and all that, right? So when you're doing anything, actually, when you're doing anything within your day, right? Let's say you're gonna do 5 tasks, right? On Monday, you're gonna do 5 tasks, right?
Oh, I
Mon-
think I got it.
yeah, what's up?
So I just thought just random thing. If you were to run 25 meters,
Mm-hmm.
if you ran like 24 meters, that means A is the distance that you ran, and then B is gonna be the whole distance. So B gets shorter while A gets longer,
Calories
right?
lost.
Oh, you're talking about like speed, right? When if A is like
Yeah.
yeah, okay, yeah, that's definitely one, right? That's definitely one. So,
We could do A is meters ran and then B is calories lost.
pardon, sorry.
A is meters ran, B is calories lost.
Definitely, definitely. Yeah, running is a very good cardio exercise. It burns a lot of fat, and it works a lot of your leg muscles too. I guess you could say when you run, right? A is proportional to B. I mean C maybe, in the sense that if you run more, maybe your leg muscles will grow, but it's inversely proportional to B because you burn more calories. If B represents calories and C represents muscles. But yeah, that's a very good example. Another thing I want to mention is that like say you're doing some stuff during the day, right? Let's say it's like a Monday. I mean during like the I don't know, maybe a Saturday, okay? Maybe a Saturday normally, right? And then like you can't like you don't have school, you're just chilling in your place, right? And then but you still got to do some chores, right? So let's split that up, right? We have like a whole day, right? And let's say like okay, we gotta account for your sleep, right? You don't wanna affect your sleep. Trust me. When you get to high school, sleep is very important. I learned that the hard way, so don't be like me,
Yes.
guys. So let's just say that's the time you sleep, right? The more like what's it called? The more time you spend on doing one thing, the less things you're able to complete within a day, right? So if I spend I don't know, like let's say I'm awake for I don't know 16 hours right during the day, and I spend 8 hours doing a, I mean sorry, I spend 8 hours doing one thing and then 8 hours doing another thing. I'm only gonna be able to complete 2 tasks in a day, right? However, if I were to do, oh no, let's say if I were to spend only 2, right? If I were to spend 2 hours, right, per task, right? Then my day would look like, you know, 2, all added up to 16. I'm gonna be able to complete 8 tasks. So you can think of it as like, this is also another thing, right? The more things you do in a day, the less time you spend on each single thing. So A is the amount of like things you're able to do, and B is the amount of time you spend on each task. So that could be also another example. Another one I want to do, maybe I'll just keep that, you know, just for reference or whatever. All right, but that's another one. That's another one. Okay, so yeah. So there's also another thing like I wanna. Okay, so who joined? Is that you, Tim? Wait. Oh, okay. Alright, I got you. Yep. So we're just gonna be going over some. Hello. Wait. Who? Sorry. Who joined? Can you just speak up real quick and tell me your name? Okay. Toxic default BT. Sorry. Who? I don't remember you guys by your I don't know, gamer tags or whatever. But sorry. What's your name? Toxic default. You with the Among Us skin. I mean profile picture. Can you hear me at least? Please type. Please let me know. This is really important to doing this lesson. Okay. Alright. You take your time letting me know. I'm gonna continue with the lesson. Okay. Oh, Jeffrey. Oh, yeah. Can you please change your server name to Jeffrey, please? I have a really hard time memorizing people's gamer tags or whatever, or internet names. But yeah. So okay, you don't know how? Oh, okay, I'll just do it for you. I'll just do it for you after I finish this. Actually, I can just do it right now, Jeffrey. There we go. All right. So we're just gonna be today. We're sorry, I think I spelled your name wrong. No, but like we're currently going over inverse proportions, right? So basically what I just went over is that instead of maybe, you know, what we dealt with last week, when A increases, B increases, this time we're dealing with when A increases, B decreases. Okay. All right. Any other questions, Jeffrey, that you have, please let me know. But I'm just gonna continue with the lesson, and the lesson is recorded, so you can always use it to refer back. So okay. So let's say, you know, these are amount of time spent on each task, right? Then I'm able to do more tasks, which if I spend less time on each task within a day. So example of when A increases, B decreases. Another example is actually when you know, like, this is a very prime example, right? Let's say we have a, you know, rectangle or something. We have a rectangle, okay? We have a rectangle. So basically, right, you guys know the formula for rectangles is length times width equals, you know, the area, right? Let's say we have a constant area, right? So length times width, let's say it equals 40, right? 40 is the area. So here is a prime example of an inverse proportion, right? You know that, you know, let me just draw out the square, maybe the rectangle, whatever. So this whole thing equals 40, the area, right? And this is the length, this is the width, maybe. So if I were to increase the length, right, what would happen to the width in order to have the same, you know, same type of area?
It gets smaller.
Yes, it gets smaller, right? And the more I increase the length, the more this is gonna decrease, right? So basically, what we have here is an inverse relationship. This is another way that inverse relationships can be defined as when two things you can adjust, right? Two variables or whatever, two different things that you can adjust, right? They multiply together to equal a constant number, constant value, and this value is called. This constant is called the I think constant of proportionality. Yes. So this is, I'm just gonna write this down. Constant number. This is the constant well, maybe as a product. Constant of so this is the constant of proportionality. And to exemplify this further, right? So here, let's say okay, I'll just rewrite this so it's not messy. Oops, someone left. So let's say we multiply the length by 2. What must we do to the width in order to have it still be 40? Do you guys know? If we were to multiply this by 2, what would we have to do to here in order to maintain this 40?
You would have to divide it by 2.
Of course. Very good. We have to divide it by 2, and as you can see, right, if we are just, doing it mathematically, we could always cross it out. We're not changing this at all. We're not changing this either. But what we're doing is that if we see that, the length were to increase by a factor of 2, right, we would have to decrease the other thing by a factor of 2. This is a really good example of inverse proportionality. When you increase something by a factor of like a number, right, you must decrease the other thing by the same factor. In this case, the 2 2's. So if I were to, increase this by a factor of 3, right, multiply the length by 3, I would have to decrease the width by 3. So this is kind of our inverse proportionality thing, okay? So, alright, before we go on to another question, I want to tell you guys something. I'm going to give you guys a little history lesson. So, are you guys familiar with, you guys know about World War I and World War II, right? So, basically, right, after World War I, Germany lost World War I as well, right? Germany, basically what happened was a bunch of countries, they kind of teamed up on Germany in the end, right? And then Germany lost World War I, and basically the winning nations, you got Britain, France in there, you got Russia in there. They demanded Germany to pay some war reparations. So I'll just write that down. I don't know, but so Germany. This relates to what I'm talking about. You guys don't worry. Oh yeah, what's up?
Wait, didn't there economy crash because the more money they printed, the worse their economy got?
Yes, that is perfect. That is exactly what I'm gonna get at. So basically, a lot of countries were like, "Hey, Germany, you gotta pay us a bunch of money, right? Because of the war, right? They're being kind of unfair, honestly." And then Germany was like, "Okay, I'll try to pay you guys back, right?" So Germany started printing out a bunch of money, right? To the point where it actually inflated the currency. And the currency itself was worth less and less and less the more they printed. So and then what happened was that they ruined their entire economy, and people had to people use wheelbarrows, literal wheelbarrows, right, to carry a heap of cash in order to just buy a piece of bread, because that heap of cash is now worth a loaf of bread. So basically, what it's like. A better way to explain this is, if before I inflate the currency, whatever, I don't know, a lollipop costs $1, right? But then I print out $4 more, right? In reality, I don't get richer, right? Actually, no, I print out $3 more bills, right? I print out $3 more bills, right? In total, now I have $4, right? In reality, I'm not really getting richer, right? I'm not gonna be able to buy 4 more of this, right? I mean 3 more of this, just because I printed out $3 more. And this is because, and if I were to actually do that what I'm really saying is that the value of this is not worth what it was before, which is crazy, because a lollipop is a lollipop. It can't just, suddenly be worth less. I don't know, for no reason, right? So now, right, the person selling me this lollipop is gonna be like, "Hey, that's unfair. Why you can't just print out more money in order to buy more of my lollipop, right? I'm gonna actually up the price on this. I'm gonna make this $4 instead of $1, right? So this way you can still use the amount of money you had, right, to buy only one of my lollipop. So that's kind of what happened in Germany, right? But So they just kept printing out more money, and people, because the money was worth less, right? It could buy less things, so they increased the prices on things. And that is another great example of inverse proportions, because the more money I print, the less it is actually worth. So, and you can think about it like like let's say this is like I don't know, the wealth of a nation, right? And then like I print out like I don't know, 1, 2, 3, 4, 6 bills, right? The more I print, you'll see that each bill is worth a lot less. So that is also kind of inflation. So inflation is a great example of this. So I'll just write it here. Inflation is a great. So guys, the moral of the story here is if you're trying to get rich, if any of you guys become politicians, you please don't print out way too much money, because that's not gonna solve poverty or anything. It's gonna make the dollar or whatever currency worth less. So that being said, okay, did somebody text? Tim, can you say something? I'm sorry if I'm looking at this late. I don't have the chat up, but can you say something, Tim, so I can see if we can hear you or not? Are you saying something? Because if you are, I can't hear you. Nothing's coming out of your mic. If you want, you can rejoin and yeah, okay. But yeah, so this is another example. I know I'm going off on a tangent here, but this is a really great example. Tim, can you speak again, so I can see if your mic works or not? Alright.
Left.
Yeah, I know. Alright, so that is okay. So now I have some questions for you. Some questions for you. Okay, so okay, the chat's supposed to. All right, so let's say a rectangle. One sec. I'm gonna do something like this. Text, right? All right, I'll leave this on screen. A rectangle. Okay, rectangle has a size 8 centimeter by 9 centimeter. Its area is 72 centimeters square centimeters. If I double the longer side and the area were to remain the same, what would happen to the shorter side? So I think.
Do I out?
Pardon?
Do I just call out?
Yeah, sure. You can call it out. It's pretty simple.
Then it'd be 4 times 18, because then you'll have to divide it. Since this is kind of like Newton's third law, right? Same equal power would be if you were to times it, you'll have to divide it, because then it'll basically the same.
Newton's third law, like motion. Are you talking about? Like Newton's third law of what?
Oh yeah. Except instead of motion, it's like when you push something, it comes back with the.
Well, yeah, that's kind of yeah. I guess you could think of it like that. It's just yeah, that's a funny way to think about it. That's pretty creative. I'm not gonna lie. Yeah, but yeah, if I do something, I'm gonna have to do something to something else so it remains the same. But yeah. I get where you're coming from. That's pretty good. That's pretty good.
The area is effectively 8. The area, if it's 9, is multiplied by 2. Then the area is just 8 times 9 times 2 divided by 2. Or you just do 8 divided by 2 times.
Hello, can you hear me?
Yeah. Yes, AG. Sorry, was that Tim? I'm on PPT. Sorry, what's PPT? Like PowerPoint?
Push to talk.
Oh, push to talk. Tim.
Yeah.
Okay. Yeah.
I use that, so that's why I don't have to go on mute all the time.
I see. Okay. All right. I'm just gonna continue with the lesson because this is recorded. So okay. So that is definitely correct, right? 8 would go down by a factor of 2, so it would now become 4, while 9 becomes 18. Hello? Yeah, we can.
Okay, now you hear me?
Yep, we can hear you now. You're good.
Okay.
All right. So that's our first question. All right, not bad, right? All right, that's our second question. You guys know Michael, right? Well, okay. Do you guys want me to read it to you, or do you guys just want to read it by yourself?
Michael, the mean Michael or the not mean Michael?
Huh?
No, like Michael's just the person in the
Yeah, the
question.
main one or the main one?
Well, oh, there's a teacher called Michael here, so. Well,
Yeah, is he like the main one that was teaching us last time?
mean one, of course, of course. Yes.
Bruh.
Okay. Just wanted to know.
It's
Just
okay,
wanted.
guys. All right, just so this. Yeah, I'll give you guys like 3 minutes. Maybe two. It's pretty simple one.
We just wait for. We just wait until you tell us to tell you the answer, right?
Oh, if you already have, I mean, yeah, it's been like almost 2 minutes, so you guys can shout it out if you want.
Oh, he's done half of the questions.
10.
Yep.
10, because I don't trust kids.
Uh huh. It's
You
okay.
you don't 'cause you don't trust kids. You don't just divide it by 2, because you're not supposed to trust kids.
Mm-hmm.
They probably have the math wrong.
Should I trust you then?
No.
Okay. Good to know. All right. So that's a pretty easy question. Yeah, he got like 10. What percent would he get? That's a pretty simple question. Just shout it out.
50%.
Yes.
Less than 50, because he's probably going to get one wrong.
Could be. Could be. Poor Michael. Okay. So here's another question. Okay. Let me just move it to frame. Okay. Okie doke. All right. I'll give you guys another maybe like I don't know 2-3 minutes.
Two minutes is up, right?
Pardon?
Is the 2 minutes up?
Yeah, you guys can just shout it now if you can, because it's like it's a pretty simple one. Yes.
6 hours.
6 hours.
6 hours, and he's gonna drive the speed of a granny car.
Yeah, true. If we were to drive down the
That is,
highway.
I could jog. I can walk that fast. I think.
No, I could crawl that fast.
I can jog that
Yeah,
fast.
so-
Never mind.
It's okay. Just pretend Michael's driving this Honda Civic, and it makes more sense.
Yeah, it does.
We're talking too much crap behind.
Too
the
much
scenes.
normal person.
Yeah.
No, we're talking too much normal person.
I'm really confused because you guys are making fun of Michael, but I don't know who Michael is, and you're like, you guys know Michael, but I don't know who he
No,
is.
he's my friend. Yeah, okay. Maybe we'll stop.
Oh.
But yeah, he's
Yeah,
just-
people make fun of friends a lot. It's very, and then he doesn't even mind, which is very funny.
No, okay. Okay, Michael's probably had enough. Shouldn't be. We should all be nice. We should all be nice to Michael.
He even agreed that he's mean.
Well, we don't want to make fun of him too much, or we'll become the mean people, right? So, all right, there's limits to everything. All right, so Newton's second law of motion. This is some physics. Then, is F equals ma. So basically, right? It's what F equals ma is. I'll just write it out here. Is amount of force, right? The amount of force, right, is equal to mass times acceleration. So acceleration is, think about like, okay, you guys are familiar with the concept of speed, right? How much you're able to traverse a certain distance over a certain amount of time, right? So distance over time. But acceleration is how much the speed is changing per unit of time. So it's actually distance per time per time. So you got distance per time squared over here. So a common unit for this is meter per over second squared. So that's acceleration. That's how much speed changes. Whereas, velocity is how much basically your displacement, your like basically like how far you're going changes, right? But like acceleration is how much the velocity or the speed changes right now. We won't go too deep into that, but like just be in mind, keep in mind that acceleration is kind of like how velocity changes. So the amount of force, right? Amount of force is 200 newtons here, right? It's being applied to a wagon. So if 1/8 of the wagon's mass was removed, so this used to be like, you know, the whole thing, right? But like if like 1/8 of it was removed, what would happen to the acceleration? If 200, this is constant.
The acceleration will be divided by 4.
Huh? Pardon? Sorry, I didn't catch that. What'd you say?
The acceleration will be divided by 4.
Divided by 4? Like this divided by 4?
Yeah, basically. So that's
How'd you arrive at that conclusion?
what?
How'd you figure that out? I want to hear.
Well, basically, since it says that 1/8 of the wagon's mass is removed,
Yep.
then to make it even, never mind. It has to be times 8.
Alright.
Time.
Keep going at it. Okay, but like what this?
So time 8.
Guys.
So basically, time 8.
Times 8. Well, guys,
Yes.
just keep in mind, right, that 1/8 of the mass was removed. So this equation, mass right here is how much mass there is, not how much is, you know, missing or whatever, right? So what's saying here is that 1/8 of the wagon's mass was removed. So if I remove 1/8 out of something's mass, right, what would be the remaining mass? What would be the mass that's actually there?
What do you?
So okay, so this is mass, right? This is, I mean, I don't know. Like, this is a huge block, right? I'm gonna remove 1/8 of it. This part's now like garbage, right? This equation, what it's talking about is this m, right? This mass right here is talking about how much mass there is, right? So if I throw this part out, how much more mass is there? Like this is 1/8, right? So if I throw this out, how much would remain?
7/8.
Yeah, 7/8 of the original mass, right? So this is the stuff that's actually there. That's gonna be affected by, you know, acceleration. Force and all that, right? So we have a constant force of 200 newtons, right? And now we only have 7/8 of the original mass left. What would happen to the acceleration? Would it increase or decrease, guys? Do you think?
Increase.
It would
Increase.
Pardon? Did anybody say decrease?
Increase.
Increase.
Increase, right? Okay, good. Because now what you're gonna have to do is to multiply a by 8/7, right? So you're not changing this. You're not changing this equation, right? You guys get that? So basically, right, you can kind of think of it like, if I'm gonna apply constant force on a cardboard box or whatever, like on a if I'm gonna move to another house or something, right? If I'm gonna move, right, and I apply a certain force, right, to a box, and suddenly this box becomes a bit lighter, I'm gonna be able to move it faster with the same amount of force applied, right? That's kind of I guess what this question is kind of close to. Any questions or anything?
I'll be right back.
Um,
I'll be right back.
Oh, you're gonna be right back? Okay, yeah, no problem.
In the equation for the acceleration, shouldn't it be 8/9? Like 9/8?
9/8?
Yeah.
Why would it be 9/8?
Like it's timed by 1.125. Like it's increased by 1/8.
Yeah, originally this was 1, right? And then you increase it by 1/8. So what's 1 plus 1/8?
8, 9/8.
Wait, hold on. No, sorry. That's not what I meant. That's not what I meant. No. Okay, I was thinking of something else. Sorry about that. No. But like, okay, this originally you could think of it as one, a coefficient of 1, right? But we're not talking about. We're not okay. This is something I want you guys to really be careful about proportions, right? It's less about adding things, right? But more about multiplying and dividing. And that's gonna sound kind of confusing at first, but let me explain, okay? So let's say that we have 200, right? We have 200 here, right? Let's say
Wait,
sorry,
isn't like the acceleration just divided by a and that's it?
acceleration is divided by 8. So
Yeah,
that means acceleration would be 1/8 the original acceleration, right? So it's gonna be way less of acceleration. So does it make sense if I remove mass and keep the constant force that it would actually decrease the speed?
yeah, it does.
How so? Like if I were to push a block, right, with a constant force, and then I'm gonna make that block lighter. Do you think I'm gonna be able to push that block faster or slower?
Faster.
Yeah. So does it make sense to have less of an acceleration as before
Um,
compared to this?
what do you mean?
So you're saying that this part should be a over 8, right?
Yeah.
A over 8. Well, this is the new acceleration, right? This whole thing is the new acceleration, right? The old acceleration is just this a. So then you're saying the new acceleration is only 1/8 of the old acceleration. It's 1/8 of that. So it's 0.125 times the original acceleration. That's what you're saying.
Yeah,
So
basically.
this is very small now compared to what it was before. So if acceleration is gonna be small, you're gonna move it slower, which doesn't really make sense, right? Because you're actually trying to, if you decrease the mass right here, you're gonna, with a constant force, you're gonna
Faster.
make it faster, right?
Yes.
So maybe I'll explain to you guys in this way, right? So you guys know that we can't really change an equation, right? If equation is established, it is what it is, right?
Wait, I have a question. So is it basically the mass? The mass is basically the opposite of the force, so it's basically what is like preventing the wagon from moving faster.
Kind of.
So
That's the concept of inertia, I guess. But you'll learn about that later on. But yeah, kind of. So, yeah, when you apply a force onto any object, right? You're gonna have to use some force to get it like moving, right? Because whatever, Newton once said that whatever stays, right, tends to want to keep staying there. Whatever's at rest wants to rest, right? While whatever's moving tends to stay moving unless some other force is applied onto it. So that's the concept of inertia. Basically, if I were to, like, if I'm gonna push you in a shopping cart. Right? This is a shopping cart, okay? I'm gonna push you in it. This is you, okay? Then I suddenly stop this cart. You're gonna fly out because your body was in motion with the body cart. Your thing was moving. You were moving. If I suddenly stop the cart, your body still keeps wanting to move, right? So you actually fly out in front and I don't know, break your neck here, which is not good. But that's another spew onto physics. But right here, I want you guys to focus more on the proportion, right? If 200, we can't change 200, and mass, right? Before it was 1 mass, right? Now it's 7/8 of that mass, and this is not 1 minus 1/8, right? We're not like adding or subtracting right here, but we're multiplying. We're multiplying 7/8 to 1, because what was, you might think, oh yeah, you said to remove 1/8, right? So why shouldn't it be 1 mass minus 1/8 mass? Well, that is, I want you guys to think about it like this, right? Before, right? Okay, maybe I'll rewrite this part. So 200 of a force, right? And then we remove 1/8 from the mass, right? And then we times a certain, now the acceleration is gonna change, right? Because this is not 1 anymore. Before it was 1. Now this becomes 7/8, right? But this doesn't mean that this is 1 plus 1/8. Just because I minus doesn't mean I multiply over here. Because you know why? I mean, sorry, just because I subtract here doesn't mean I add over here. And this is why, right? So we're dealing with coefficients here. And mass and acceleration, these aren't units, right? Don't think about them as units. Think of them as like variables instead, right? Maybe mass is 20 kilograms right here. Maybe acceleration's 10 meters per second square right here, right? But these could very possibly be values as well. All right, here's what happens. This is why we can't just add over here when we subtract it over here, okay? Look at it like this. So this becomes, right, hypothetically, this becomes 200 equals to 1, if you distribute it like this, right? M times, this is A, plus 1 over 8A, right? So we still have, you know, this 1M and 1A thing as before, right? However, we now have minus 1/8M and plus 1/8A. And now I've never said that these were equal. These are very much not equal, actually. So what I did here was to change the equation. This is why you can't just add onto the coefficient when you're trying to multiply or to something. The whole point of proportions is that, you know, when I increase something, right? If I increase A by a factor of 2, well, I don't also increase B by 2. I increase B by a factor of 2, right? And here's the thing with inverse proportion as well. If I increase A by a factor of 2, right? I don't take away 2 from B in order to make this thing like equal or equivalent, right? I actually have to divide B by 2. So if I multiply 2 to A, I have to divide 2 from B, right? So that's kind of the same thing here, right? This is wrong. This is wrong, okay? But good attempt though. It's a pretty common thing for people to think, so don't worry about it. But so we have originally, right? Maybe I'll write the equation f equals ma, right? 200 equaling to m times a, right? But now it's 7 over 8m, right? So I before, right? Our example of a and b, I multiplied a coefficient of 2 to b. Therefore, I must divide divide the number 2 from b. So if I multiply 7 over 8 onto m, what must I do to a?
Divide it
Yes.
by 7/8.
Yes, divided by 7 over 8. And as you know, when you divide a fraction, right, it becomes the reciprocal, right? 7 over 8, like when you divide a fraction, you're multiplying its reciprocal. So, are you guys familiar with that? Dividing fraction and all that? You guys comfortable with that?
Yeah.
Yeah, right? So this actually becomes 8 over 7 times a. So this is times, right? So what you guys can see here, I actually have not changed the original equation. I have not changed this at all. Okay? Oh, sorry, not that. I have not changed this. Because, you know why? If I were to I could just simply cancel these out, and it would just be 200 equals m times a, right? Instead of, like, 200 equaling to m minus 1a m times, I don't know, like, it's some weird stuff going on right here, right? But this is the whole concept of proportionality, right? We actually do a lot more of multiplying and dividing than adding and subtracting when it comes to proportions. So, any questions? Are you guys okay with this? How do you guys feel? Is silence your way of saying yes, Alex is very good, or no, Alex, this sucks?
That looks very good.
All right. No, like, I'm being serious though. Like, I want to make sure that you guys
Yeah.
all like comfortable. Okay.
For me, it's good.
All right. How about people other than Tim? How do you guys feel?
I feel this is good.
You feel good? Okay. Edward, how about you? How do you feel?
Oh yeah, it's pretty good.
Yeah.
I understand.
All right. Jeffrey, how about you? Are you still confused, or how do you feel about this? What I just talked about here. Are you comfortable with it? Like, do you understand? Jeffrey? I can't really hear you, but can you type it? Just let me know. All right. How about you, Patrick?
It's It's okay.
It's okay. All right. All right. So you guys, what I'm getting at is that you guys are okay with this. All right. Perfect. Don't worry if you guys are still a bit confused. All right. I'll include some of these in the homework so you guys can get like adequate practice. But yeah, if this is something new to you, I understand. It's kind of counterintuitive, right? It's not that, it's not like bam right there, right? It's kind of like, you know. So that's basically all I have to really say about inverse proportions. What I'm gonna do now is maybe do some review practice with you, for the entire proportions stuff. All right, so I'm gonna try to screenshot this thing. One sec. Snipping tool. Snipping tool. Okay. New options. All right, I'm gonna. Okay, this is taken from this this book that I'm using, but all right. That's what I'm gonna do here. All right. If 4 glyphs are worth 3 glops and 2 glops are worth 5 glyphs, how many glyphs are worth the same as 10 glyphs? It's like I'm reading a Dr. Seuss book almost. I'll give you guys a little time with this. You can always speak up if you guys need any hints or whatever. I'll give you guys maybe 2 minutes. 2 minutes. I'll check on you guys at 11:49. By the way, if you're done, let me know so I can move on.
Yeah, I'm done.
You're done? Alright, good. Anybody else done?
Can we use paper?
Of course, feel free to use any.
Oh,
Yeah, you don't have to use your brain. Let me just make it clear for you guys. If you guys want to use a calculator, you guys don't have to, like, if it's like 372 times 500.7, I don't know. You guys can use a calculator, right? If it's something that you can't do it immediately in your head, especially those simple calculations, you guys are allowed to use calculators. You guys are definitely allowed to use paper. But yeah, feel free to use any resources that you like that would help you, except the internet. Don't search up the answers, please.
Do something to
Pardon?
like the answer.
Sorry, what'd you say?
Can you just shut the answer out loud?
Let's wait for everybody to be done. How's everyone doing? I want to answer from all 5 of you. Yes or no? Done or not done?
I'm getting mixed up because I thought there were 2 glyphs, but it's actually 3 glops and 2 glops, or 5 glyphs and gleeps, and I'm really
Yeah, it's this is the tricky part, and it's sometimes the word used, but how about I give you guys like 40 seconds. So like, well, 11:51.
Wait, is it a decimal number?
This one? Actually,
Yeah.
I'm not too sure. I'm not actually. I don't think so. I'm not too sure. I actually haven't done this yet. I'm just gonna do this right now quickly.
What did it mean by 3 and 2 glops? Can you just say 5 glops?
Oh, 3 and 2.
Do they 5 glops? Because I'm confused.
Okay. How about this? We'll just do this together. All right. Well, let's do this together. So okay. Gleeps, glops, glips. They're all really
Okay.
confusing, right? So let's just
Yeah, so basically how I did it is the 10 groups are with 3 blocks and 4 groups of 3 blocks, and that means three well 3 quarters. Just you multiply the amount of groups by 3 quarters, then you just multiply then just divide 5 grips by 2 blocks, which is one by 1 block. So it's 2.5. So just divide the first answer by the
Alright.
second one as well.
all right.
I multiply the first answer by the second answer.
Okay. Let's just that sounds pretty good. But like let's do this together. So like, gleeps, right? Equals maybe x. All right. Let's call it x. All right. Glops equal y. All right. And glips equals, maybe I'll use a, b, c. It's better to write. I like to use a, b, and c. All right. So if 4a equals 3b and 2b equals 5c, so it's x amount of like x is what we're trying to, like, how many, right? That's the x, right? How many glips, so how many c's are worth the same as 10a. All right, so we have, so a great way to start this is, we see that, you know, we have a relationship between a and b and c, and we're trying to figure out the relationship between c and a, right? So what we can do is change this relationship of between a, right, into b, so we can have the direct relationship between b and c. If that sounds confusing, basically what we're trying to do is convert a to b and then convert b to c, so we can see how much x is. All right, so in order to convert a to b, I'm just gonna move this down here. Okay, I'm just gonna move this down here. I'll move this over here maybe. Okay, so in order to convert a to b, right? So what is a in terms of b, right? So okay, maybe I shouldn't have this underlined here, but yeah. So all we have to do to isolate a, right, is to move 4 to the other side, right? So we have 3 over 4 b equals a, right? So right here we could just convert this 10a into b, right? So we have 10 and then a equals this, so we just 3b over 4, and so x amount of c would equal to, that's 2 5, that's 15. Wait, 15 over 2b. All right, so now what we have to do is to convert b to c in order to see what x really is. All right, so over here, maybe I think this is getting pretty good. I think I'll let you guys carry on with the rest. You know what? Heck, whatever. We'll just do it together as a teamwork. So converting b into c, right? Moving 2 to the side, we have 5 over 2 times c, and if we just sub this in, right? So x times c equals 15 over 2, right? And b equals 5 over 2c, so 5 over 2c it is, right? And then what we do is we multiply them together, right? So xc actually equals to, 15 times 5, so that's 75 over 4c, right? And then what we could do right here, if x amount of c equals to 75 over 4 amount of c, we know that x is going to be equal to 75 over 4, because, what we could do is just cross out the c, to be honest with you. We have x equals 75 over 4. How do you guys feel about this? Was it okay? Was it the words that made it confusing for you? How do you guys feel? Let me get a nice answer from you guys.
I feel like grapes, globs, and glips.
You feel like, yeah, I'm not even gonna say that, but Okay, how about everybody else? How you guys feel? Was
Well, I
that
got
going too fast? Do you guys want? Sorry, Adrian.
well, I got a
I'm just confused on words.
Okay. Wait, sorry, Adrian. What were you saying?
good because I got the answer right.
Pardon?
Well, I got the answer right, so I guess I feel good.
Yeah. Well, yeah, definitely. That's good. That's always good. Yeah. If you guys find out, like, whenever you guys have like things that are confusing, always simplify, right? Always simplify. Whenever, this is the general philosophy in math. You see something you don't like, you hate, you think it's too confusing, you find a way to simplify, and this way you could use letters or anything. All right. So we're gonna do another question. 1 second. 1 second. All right, this isn't bad. Okay, so this requires a little bit more math work, but it's also about ratios. All right, so just paste it here. If the ratio of 2x minus y to x plus y is 2 to 3, find the ratio of x to y. I'll give you guys maybe, I don't know. I'll check in on you guys maybe in 3 minutes or so. Yeah, at 12, okay? I'll check in on you guys. If you finish, please just shout it out. Let me, or type in the chat if you don't want to shout it out. And just let me know, because I want to see how much of you guys are finished so we can keep moving on. Alright, go at it. you guys doing?
I think it's 4 to 5.
4 to 5?
Yeah.
Alright. That sounds pretty okay. Anybody else? Any other answers? Alright. So who said
iPad's on 5 battery.
Pardon? Edward?
My iPad's on 5 battery. 1 sec.
Okay, yeah. Okay, so sorry, who said 4 to 5?
Me.
You? Okay. Do you wanna tell me how you did it?
I might be wrong though.
No, it's okay. Just tell me how you did it. Like, I don't want to see the process. Honestly, guys, like, I care about your process way more than your answer, because your process show like how you thought of it and like, what approach you did, and your answer is just if you thought of it like in a certain way, then you get your answer. Anyways, right? If you think of certain things a certain way, you're gonna get the answer nonetheless, right? Nevertheless, right? But what's important here is your process. So I want to hear your process.
So 2x minus y,
Uh-huh.
2x plus y, so equals 2 to 3.
Sorry, 2x plus y?
No, I mean x plus y. Sorry. 2x. 2x plus y equals 2 to 3.
Yep.
So my dad taught me before that if two of these comparison equations
Yep.
have the same are the same,
Yep.
then if you times the left part of one but the right part of the other, the answer should be the same. If you time
This
the
part by this, right? And this part by this?
Yeah.
Yeah.
between those should be the same.
Alright.
So
So
I calculate.
so this, right? I mean this, right? Did you do this?
Yeah.
Okay.
Yes.
So you would get 6x minus 3y, right, equaling to 2x plus 2y, right? And then what'd you do after this?
And then I exchanged the 3y with the 2x. So now the left side is 6x minus 2x, and the right side is 2y plus 3y.
Yep. Okay. So this would
And
become
4x to 5y. And that's 45.
okay. Not bad. It's pretty good. Like your way of thinking. Anybody else get any answers? Whatever. Well, okay. Here's one problem I have with this. Okay, I like your way of thinking, and this is like a good approach, right? But the problem over here is that I'm asking what's x to y, right? And over here, yes, we have an x and a y over here, but mind you, this is currently what we currently have is actually 4x to 5y. We don't really have x to y. Okay, we don't really have x to y. We have 4x to 5y. Do you understand? It's like, how do I say? I'm looking for a concrete relationship between x to y, not necessarily 4x to 5y, right? Because here's the thing, right? If we're dealing with a ratio, right, x to y, right? If I multiply 4 to x, right, I should multiply 4 to y. It doesn't make sense for me to have like suddenly 5y over here. So yes, 4x equals to 5y, right? But the problem is that's not what I'm looking for. You're correct in this step. You're definitely correct, but sadly, this does not equal to the fact that x to y is 4 to 5. Think about it, right? If x to y is 4 to 5, right? If x is 4 and y to 5, for example, right? So if I multiply x by 4, right? 4 times 4 equals 16, and 5 times 5 equals 25, and that's simply not true. So I want you to keep thinking, but like you're definitely on a really good track here.
Oh, yeah. Then I think basically will be 1 to 1.25.
Okay, 1 to 1.25, right? Wait, sorry. One like 1 as in x and y as in 1.25,
No.
right? Because if I put like 1, sorry, if I put 1 into x, right, and 1.25 into y, this would still not equal. A little hint maybe is that I'm looking for okay, sorry, Patrick, do you know why you multiplied this with this and this with this? Do you know why?
I want to be able to find like something comparable between the two, other than to know the equals between the left equation and the right equation.
You want to find something else? Okay.
Comparable.
Compare. Okay. All right, but like, do you know why this works? Like, I just want you to answer. Like, do you know why you're able to multiply this by this and this by this?
Because because essentially they represent the same thing. The left part of both represents the same thing, and the right part of both represents the same thing.
Yes, they definitely do. They're the same thing. Yep.
No, the left parts of both.
Yeah. I know what you like. These are the same thing, and these are the same thing, and they remain. This maintains a 2-to-3 ratio. All right, but like that's. Yes, you're giving me a fact that you're able, just because they're the same, you're able to multiply, but why multiply? Why not divide? Why not add? Do you know why you have to multiply them?
Okay, because when you okay.
Oh, you can take your time to explain, don't worry. Like, you telling me 2x minus y, that is the
Because
same as 3, and x plus y is the same as 2, but why multiply?
when you multiply, the the result can be changed through additional processes, additional multiplication and division processes, so that it can match the other results.
Yes. Okay. Hold on. Patrick. I'll tell you what. Like, this is what I meant. All right. You're giving me really good responses, but like, here's what I was talking about. Right. So when we have a ratio of 2x minus y to and this, basically what we're saying, the ratio of this to this is 2 to 3, right? What we can actually do, right? Okay, so basically the ratio, we're dealing with a ratio, right? So this 2 to this whole thing, right? Let's just pretend this is, I don't know, like 8 to 12, all right? Pretend, okay? So if we divide 8 by 12 and 2 by 3, we get the same exact value. So 8 over 12 equals 2 over 3, right? And you know that 8 to 12 maintains the same ratio as 2 to 3. Therefore, if this maintains the ratio of 2 to 3, when we divide 2x minus y over like this, it should equal to 2 to 3, because these are ratios. We're dealing with ratios, right? It's like me saying, oh yeah, the numbers, again, it's like me saying the numbers 8 to 12 are, you know, the same ratio as 2 to 3. If this is true, I'm able to divide 8 by 12 and I would get 2 to 3, and 2 to 3 is obviously 2 over 3. So mind you, this is and this is why your thing works, right? You see that 2x minus y, it's this thing right here, right? And then it corresponds to this 2. Sorry, to it kind of, okay. So this actually, it doesn't correspond to 3, but it actually corresponds to 2, because you know why? We're saying that in a pie, right? If I split this into 5, right? 2x minus y would cover up two slices of this pizza or whatever, and x plus y would cover up this three slices. All right, so that's the whole concept of ratios. So it's about more of how large they are relative to each other. Okay, how big they are compared to each other. So look right here, we have kind of like a fraction equaling a fraction, right? What we're able to do here is multiply 3 on both sides to get rid of the denominators, right? Because they're kind of annoying. All right, so we have 3 times 2x minus y equaling to this is over x plus y equaling to 2, right? And then all we have to do is multiply both sides this time by x plus y, right? So if I multiply x plus y right here, x plus y, you'll see that what we end up with is 3 times 2x minus y equaling, why did I write equal sign 2 times here? Okay, equaling to 2 times x plus y. This is why this works. This is why you're able to straight up say, oh, when we have two ratios like this, all I have to do is multiply this to the left, to the left side of the left, to the right side of the right, and multiply these two together. This is why you're able to do that. It's because of this fraction. You're essentially working with fractions. That's why. So, and you see this step is the exact same as this step. Do you guys get this? Is this good for you guys? All right. No, but Patrick, it's a very, very cool thing that you brought up. Thank you for bringing it up. It definitely helped me with explaining my stuff. But yeah, and having said this, let's talk about this stuff. All right. We have 4x equaling to 5y, but what we're looking at is we want x to y. Right, we can convert this into a fraction to make our life easier. We can actually say what we're looking for is actually x to y. If this equals some, I don't know, random number, I'm just gonna think of a random number right now. Let's say if this was 17 over 3, then that means x will be 17 and y will be 3. So my ratio would end up being 17 to 3. But that's just imaginary, right? That's just an example. But we have this thing. How do we figure out what x is and what y is? Well, we can simply isolate. And this is what I mean, like 4x equals to 5y, right? And then what would x be?
Five y. Wait, no.
Yeah, keep going.
Wait, no.
No, keep going. Don't worry. How do I move 4 to the other side? What would it be?
Divided by 4.
Yep, divided by 4.
Yeah.
So this is our value for x, right? We already kind of almost got half the puzzle done, right? Now, what would y look like? Right? We have the same thing with 4x equals 5y. What would y look like?
X is equivalent to 1
What?
plus
Divided by
5y.
y.
Yeah.
Equals 5.
No, okay.
Divided by 5 equals y.
Yeah. Good. So, we have now a definition for x and a definition for y. We now know technically what x is and what y is, except that we have this little variable inside of each one of them. But we'll see later, alright? So, we're trying to figure out the ratio of x to y, right? So what we can do is we set it up as a fraction, right? And x right here, we know that x is 5y over 4, right? So we could simply say, oh, this is the same. If I just were to plug this into x, right? This will be the same, exactly the same as 5y over 4 all over, and this is y, right? So 4x over 5. These are the exact same, okay? So all we have to do is simplify a little bit. So 5y over 4 and all divided by 4x over 5. What would this be? You guys know how to work division of fractions, right? So what would this be, guys? Oh, if you have an answer, just shout it out. That works. Wait, you guys know how to? Okay, so,
One.
pardon?
1.
1. This thing equals. Are you saying this equals 1?
Yeah, but because basically x equals 1, so it's 1.
How do you know that x equals 1?
I said x equals y because it's on the side.
Well, x
You have to-
actually, look, x actually doesn't equal y because previously we established that 4x equals 5y. So, based on this, x cannot be y actually.
Oh, okay.
Yeah.
Oh, x ratio. I thought I was like a quick. Oh, never mind.
No. Okay, this transform into this, and yeah. Sorry, who? Someone was trying to say something. Was someone trying to say something? All right. You guys know how to divide fractions, right? So this is
Yeah.
okay. So we have this is essentially right, 5y over 4 multiplied, but the reciprocal of this. What's the reciprocal of that?
Is that 4 divided by 4?
Sorry, your mic cut out. What'd you say?
5 over 4y.
4y.
No, 4x, my
Yeah,
bad.
no problem. All right, so 5 over 4x. All right. So x over y equals 5y over 4 times 5 over 4x. So what we can deduct from this, right? You see, this is kind of similar to 5 over 4y, right? This is the exact same as this, right? And what we can do, because it's all multiplication, right? We could just multiply the coefficients together, giving us. Oh, sorry, I didn't mean to do it like that. Multiply by x is at the bottom, right? So this is actually that. So because this is all multiplication, right? We're able to 5 times 5, 4 times 4. So if I move the coefficients to the front of this part, right? What would it be? What would the coefficients be? 5 times 5 over 4 times 4. What would that be? And then what would this look like? Is this confusing to any of you?
Wait, let me see.
So what we're doing is we're just multiplying these together. Like I might have made it look kind of messy over here, but maybe I'll just we're just multiplying this all together. It's all getting multiplied. What would this look like? So this is the exact same as this.
没有摩托，但是觉得很大。
Alright guys, what's 5 times 5?
It's 25 divided by 16 times y by x.
Yep. So okay. So
Oh, I thought you wanted answer for the whole equation.
no. I'm so sorry. I didn't mean that. But I just wanted to do it step by step. I'm so sorry about that confusion. But 25 over 16 times y over x, right? Now we have this y over x here, and then x over y here, right? What we're really looking for, right? Is x over y, right? We don't really want, part of our question to be in our answer, right? So what can we do to kind of, move this? How can we move this around so that we only have like a number at the end? I'll maybe rephrase that. So we have x over y right here, right? Technically, we could just say that x over y equals 25y over 16x, right? But I'll let you guys see why that's the problem, right? We're actually not done at this point because why? We're saying that 25y equals 16x. Well, then we can just reduce it as 5y equals 4x, and we actually haven't solved our beginning problem. We're back to square one, maybe we're back to here. So we're actually not done the problem. We can't just leave our answer like this. So and this is why we can't really have like part of our question. This is why we can't have part of our question in our actual answer. it's because we could just rework the steps and get back to square one, and this is not helpful to us. We don't really know what x and y really are, right? We want to kind of express them as a number as much as we want. So that being said, how can we, you know, make it so that x and y are all on one side? Did anybody want to say something? Sorry, Patrick, your mic cut out. I'm so sorry. I didn't hear you.
You can you can like bring you can like bring the y over x to the other side.
Yeah, definitely. So what I can actually do right here, right, is multiply x on both sides and divide by y on both sides. So basically removing this all the way over here. And guys, what would this side be after I move this y over x over here? What would this be? Mind you,
X
sorry?
Well,
over y divided by y over x.
Yeah, so x, y divided by y over x. So what would this be? What would this be?
Y times xy.
Y times xy?
X over y times x over y.
All right. Does anybody know like a good way to express this so that I don't have to write out two x's?
2x over 2y.
Oh, but this is multiplication. When you have 2x over 2y, right? That's saying x plus x over y plus y, but we're actually dealing with multiplication. Are you guys familiar with exponents?
Yes, x over 2
Yeah.
divide over y over 2.
Over 2?
2 over y to the power of 2.
Yeah, so x, yeah. You're talking about this, right?
Yes.
Alright. Equaling to 25 over 16. So, but, okay, this is very useful now. We don't have x and y in our answer anymore, but the problem now lies because we're really looking for x over y. We're not looking for x squared over y squared. So does anybody know how to change this into x over y instead of x squared over y squared? Does anybody
I
wanna-
think
Yep, Edward, what's up?
our root 25 over 16 and x over y too. Yeah,
Yes,
definitely.
definitely. 25. So this would actually be, okay, so now we have x over y equaling to square root of 25 is 5 and square root of 16 is 6. So the ratio of x to y is actually 5 to 4. And now here's the thing I want you guys to notice. Is it possible to have, like, is this our only type of answer, right? Because look, what we're saying is that whatever we plug in for x and y, it should satisfy 25 over 16. And currently we have x is equal to, 5, x is equal to 5, and y is equal to 4. So if I plug that in, 5 squared equals 25, perfect. Y is 4, 4 squared equals 16, 25, which brings together 25 over 16, which is perfect. But is there any other value that could work, that could also bring us 25 over 16? Have you guys done a lot on exponents and all that? Or multiplying stuff together? Yep. Anyone want to make a suggestion? Alright. So let me just maybe do this, alright? So 2 times 2 is 4, right? So basically 2 squared is 4, right? But what other two numbers that are the same that multiply together to equal 4? So this is 2 times 2 equaling to 4. But what other two of the same things that can multiply together would also give us 4? You guys know? And this requires for you to think a little bit outside the box, maybe. Doesn't have to be a positive number. Sorry, Patrick, are you trying to say something?
No.
Okay. So what? Okay, so instead of maybe having 2 times 2 equals 4, right? We can also have -2 times -2, giving us 4. Again, this fits our criteria of 2 of the same thing equaling to 4. So basically, right, 2 squared is 4, but -2, this whole -2 thing squared is also equal to 4. Now here's a few things, right? I want you guys to be careful. -2 squared is not the same as -2 squared. So -2 squared, this is -2 times -2, right? Which equals 4, right? But what this is that this is a negative multiplied by like 2 to the power of 2, which will give us actually -4. So these two are not the same. So make sure you guys, know, you guys know the difference, all right? But so basically, what I can say is when x squared equals 4, right? And I apply, the square root thing on both sides, right? Now I know that x, what I'm saying is x times x equals to 4. But however, there could be 2 answers for x. One could be 2, one could be -2, right? So over here, what we actually do is x, because we know it could be positive or minus, right? We actually do plus or minus 2. X equals to plus or minus 2. So what this means is that x could either be 2 or x could also be -2. Both of them work, all right? So there could be 2 answers for x. And now the same concept is over here, is applied over here, all right? So when x squared equals 25 and y squared equals 16, right? When I square root them, this doesn't have to be only +5 and +4. It could also be -5 and -4. Watch, because if I put x as -5, right, into x squared, -5 times -5 is 25. -4 times -4 is 16, and that still works. So sometimes you guys gotta watch out for the plus or minus stuff. Like, I'll include some of them in your homework, and I'll definitely. So the answer to this, to wrap up our question, is that x over y is actually plus or minus 5 over 4. So what this means, right, is if I go back here, of a ratio of this to this is 2 to 3, right? So 2x minus y. Let's say, for example, right, let's pretend that well, this is also where you have to be careful, okay? I don't want to confuse you guys too much, but we had our answer could have been +5 or +4. I mean, or it could have been -5 or -4. But here, I want to ask you guys a question. Is it possible to have okay, I didn't write that proper, but is it possible to have -5 and +4? Is that possible? Do you guys think this is possible?
Yes, I think so.
What?
Because they're separate equations for.
But here's the thing you gotta keep in mind, right? If 5 is positive and 4 is negative, right? Then back here we've made this statement, right?
The answer's gonna be negative.
If one's negative and one's positive, they would not equal, right? So here's the thing about math. Here's the stupid thing about math, is that sometimes you really gotta look out for things like this, right? You might arrive at your answer, you might get lost in your work and say, oh, this could be plus or minus 5 over 4. So x could be x could be like +5 or -5. Y could be +4 or -4. So basically, from that you might think, oh, x to y could be -5 to 4, which is wrong because of things you've established earlier. This is why it's good to like check over your work sometimes and like plug things in to see if it works or not, because we know from here that negative and a negative works and positive works, but negative and a positive or positive and a negative would not work in this case. Do you guys understand? It's kind of like over here you made a statement, right? It's like you wrote it down, you kind of made a statement saying that, oh, 4x equals 5y no matter what. All right, so now this part, right, x, right, I could say, oh, it's -5, y could be -4, so this whole thing would be -20, equaling to negative 20, which is true, right? It could have also been, 4x equals to 5y. So, I have 5 4x, right? So this x equals 5 and y equals 4. So 4 times 5 equals 20 equals 20. 20 still equals 20, so that still works. But however, I cannot have when a negative and a positive, because now I'm saying negative 20 equals to 20, which is wrong. So that's the thing you guys need to be careful of, right? Is what can I actually work with? How should I actually express my answer, right? In this case, you would necessarily express it as plus or minus. Maybe instead you just want to say 5 over 4, because if it's negative 5 over negative 4, that cancels out. But saying that it's plus or minus 5 over 4, we're including the possibility of negative 5 over 4, which is not true, because that implies either one of these has to be negative. Either 5 or 4 or 5, one of them has to be negative, which is not true, as we said. So how do you guys feel about that? Good? Bad? Any questions or something? Hopefully I didn't confuse you guys. I'm really sorry if I did, and trust me, like, if you guys are still confused about what I've said so far, you can feel free to DM me at any time on Discord, right? I'm basically always online.
I'm good.
You're good? All right. If anybody, how are everybody else feeling besides Tim? Tim's quite active.
It's okay. Yeah, I got it.
It's okay. All right, that's good. So if you guys have any, I'm gonna send out the homework probably this afternoon sometime. I do have some stuff in the early afternoon. Maybe I'll definitely get it out, the homework out, by tonight. But yeah, you guys, yeah, any questions, don't hesitate to ask me at all. Trust me, I'm here for you. I'll be always helping you. And with that, we'll conclude our lesson. Thank you so much, everyone, for coming here today, and I hope you guys have a great lunch. Alright, you may leave the call.
Thank you.
No problem. Bye, guys.